What we're talking about today is lesson 64, inverse variation. Recall, direct variation between two variables is when y is equal to kx. That is an equation that you should already be very comfortable with. We've used it for a while now, several lessons, so you should know this equation. And what we're talking about today is inverse variation, which is a relationship between two variables whose product is a constant. So our two equations for inverse variation are xy equals k, this is where we're getting k by itself, or y equals k over x. Okay, this is the equation for direct variation. This is where we're getting that constant by itself. So again, k is the constant of variation, and it says whenever it's in words, y varies inversely with x. So whatever that first thing it is they're talking about, that's going to be our y, and it will vary inversely with x. So what it wants us to do is tell whether each relationship is an inverse variation. So before we can do that, we have to remember that inverse variation is in the form of y equals k over x, okay, or xy equals k. Alright, so what I would like to see you do is to get y by itself to see if you have k over x, your constant over your x variable. So to get y by itself here, I'm going to multiply by y on both sides. When I do that, y's will cancel, and I'm left with xy equals 36. Well, what this is the same as this one, so that tells me immediately that it is inverse variation. If I wanted to take it further to get y completely by itself, I would divide by x on both sides, and that would get me that y is equal to 36 over x. It is inverse variation. On B, same thing. I want to see if I can get it in the form of y equals k over x, or xy equals k. To get y by itself here, I'm going to multiply by 12 on both sides. 12s will cancel, so I'm left with y equals 12x. Is this inverse variation? I hope that you're thinking no. This is a type of variation. Notice that I have y equals a constant times x, or y equals kx. This would be direct variation. Okay, so not inverse variation, but it is direct variation. The product rule for inverse variation is that if x1, y1, and x2, y2, these are just 2 points, this is coordinate 1 and coordinate 2, are solutions of an inverse variation, then x1, y1, and then x1 times y1 equals x2 times y2. So it says, if y varies inversely as x, and y is equal to 5 when x equals 12, find x when y equals 3. So this is our y sub 1, x sub 1. We want to find x sub 2 when y sub 2 is 3. So our equation was x sub 1 times y sub 1 is equal to x sub 2 times y sub 2. So I'm just going to plug everything in. Instead of x sub 1, I'm going to put my 12. Instead of y sub 1, I'm going to put my 5. That's equal to, I don't know what x sub 2 is, that's what I'm trying to find, and y sub 2 is 3. So 12 times 5 is 60, which is equal to 3 times x sub 2, which is 3x sub 2. To get x sub 2 by itself, I'm going to divide by 3 on both sides, which will leave me with x sub 2 is equal to 20. That is my final answer. Okay, so this is the product rule for inverse variation. Oops. It says, write an inverse variation relating x and y when x equals 2 and y equals 6. Then graph the relationship. So I'm going, first of all, I know I'm dealing with inverse variation, so I'm going to write my two equations for inverse variation, which is y equals k over x, and xy equals k. Since they're giving me x and y, I'm going to use this equation to find out what my k is so that I can plug it in here to write my equation. So I have, instead of x, I'm going to put 2. Instead of y, I'm going to put 6. And that has to be equal to k. So 2 times 6 is 12, so that means that 12 is equal to k. So my equation for inverse variation is y equals 12 over x, because I just plugged that in for that k. Now, if you have a graphing calculator, all you have to do is punch this into your y sub 1 and then hit graph. So you have y sub 1 equals 12 divided by x, and you can graph it. If you don't have one, then you can set up a nice t-chart. Okay, and I'm going to use numbers that I know will divide evenly into 12, so that it'll graph nicely. So I'm going to use -4, -2, 0, 2, and 4. Okay, so if I put -4 in here, that means I have 4 divided by -4, or excuse me, 12 divided by -4 gives me a -3. 12 divided by -2 gives me -6. $12 divided by 0, I can't do it. Okay, I'm going to get an error here, because I can never divide by 0. I don't know how to do that. So then I have 12 divided by 2, which is going to give me a positive 6, and 12 divided by 4, which is going to give me a positive 3. So what I have, draw my graph. Okay, and I have, let's go, 1, 2, 3, 4, 5, and 6. 1, 2, 3, 4, 5, and 6. Okay, so my first point is at -4, -3. So I'm going to go left 4, down 3. 1, 2, 3. Next point is at -2, -6. About there. My next point is at 2, 6. Then my next point is at 4, 3. So I'm going to go over 4 and up 3. So you can't see it very well. If I went a little farther, I could go a little farther, and if I put 6, that would give me a 2 here. So I'd go over 6 and up 2. So I can kind of see that my graph is going to look like this. Okay, whoops, it should hit that point. And I have an asymptote here because this is undefined. Okay, so it's going to get as close as it possibly can here, but it's not going to touch. I'm also going to have an asymptote here. Okay, and it's going to get as close as it can. It's going to continue to get closer, 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 but it's never going to cross that axis. It will not cross the x or the y axis. If Maria is riding her bike at a rate of 12 miles per hour, it will take her 1 3/4 hours to reach her destination. How long will it take her if she travels at a rate of 18 miles per hour? Okay, so what they're giving me here, okay, is two separate things. I know that she's riding at a rate of 12 miles per hour, and that's going to take her this long. And I also know, I want to know how long it'll take, if she's traveling at a rate of 18 miles per hour. So essentially what they're giving you is they're talking about the dirt formula, D equals RT, and they're giving you a rate and a time, and then they're giving you a rate and they want to know the other time. This is the same thing as our inverse variation equation. I'm going to have x sub 1, y sub 1 equals x sub 2, y sub 2, and it's going to be my rate and my time, my rate and my time. Okay? So I'm going to plug in my time for x here, which is 1 3/4 hours, so I'm going to put 1.75, and my rate for y, which is going to be 12, and that has to be equal to how long, we don't know, times our rate, which is 18. So, I don't know off the top, 12 times 0.75 is going to give me 21, which is equal to 18 x sub 2. To get x sub 2 by itself, I'm going to divide by 18 on both sides. Okay, well that's not going to work out evenly. I have x sub 2 is equal to, it'll go in one time evenly with a remainder of 3, so I have 3 over 18, which is the same as 1 and 1/6 hours, okay, which I could find an exact amount of time because a sixth of an hour is going to be 10 minutes, right? So 1 hour, 10 minutes. And that is my final answer. That's all I have for you today. I hope that you've taken good notes and that you have a good night. I'll see you in class tomorrow.